Okay boys, here's a bit of help for you on powers of directed numbers, which is on page 109 to 111 of your textbook. You should have written in your exercise book the key ideas on page 109, and I've summarised those key ideas right here. Now, so we've got to remember that any number raised to an even power is positive. So an even power, by that I mean a power of 2, 4, 6, 8, etc. So if I've got, for example, negative 2, and I raise it to an even power, to the power of 2, I know that that's equal to negative 2 times negative 2, don't I? And a negative times a negative, we know, is positive. Okay? A negative number raised to an odd power is negative. So let's take negative 2 to the power of 3. And as I was explaining in class, what you do is you count up the number of negative signs. In this case it's 3, and if it's an odd number, so 3 is an odd number, 1, 2, 3, then your answer is going to be negative. So our answer here is 2 times 2 is 4, 4 times 2 is 8, my answer is negative 8. Okay, a positive number raised to an odd power is positive. So it doesn't matter what the positive number is. If it's 2 to the power of 4, sorry, an odd power I said, so 2 to the power of 3. That's simply 2 times 2 times 2. And notice I haven't bothered putting in the positive signs, they're not needed, even if my question was like so. And we know that that is equal to 8, and we don't really bother with a positive sign right there. Okay, let's try some examples that are very much like question 4 on page 109. What we need to do in question 4 is write an expanded form the numbers you see and calculate the answer. So let's get rid of this for a bit and move it up there. Okay, so these are questions like you'd see in question 4. What is positive 5 raised to the power of 3? Well, it's simply this, isn't it? Now I'm not going to bother writing in the positive signs because they're just not really needed. And that's going to equal, from your calculator, 125. And again, I don't need a positive sign here. Alright, a second example might be this. Negative 2 raised to the power of 4. Now that's equal to negative 2 times negative 2 times negative 2 times negative 2. And the number of negatives is even. There's 4 of them, isn't there? 1, 2, 3, 4, like there. So we know we're looking at a positive answer. Remember, any number, positive or negative, raised to an even power is going to be positive. So we go to our calculator and discover that 2 to the power of 4, notice I said 2 to the power of 4, I'm ignoring the fact that it's negative, is equal to 16. Okay. Now on your calculator what you can do is use the power key. On some calculators it looks like this, the older models. On the current Casio models it looks like that key there. And so what I can do is, if I'm using this model here, is just go negative 2 in brackets. Oops. Make sure it's in brackets, otherwise your calculator will give you the wrong answer. You try it. Raise to the power of 4, so you enter 4 there, and press equals, and the answer that pops out will be 16, as we've got here. Okay, so I don't mind you using your calculator for these ones. Let's have a look at the powers of negative 1, and we'll notice a pattern that develops. Okay, so the first one we're looking at is negative 1 raised to the power of 2. So we know that that equals, for sure, negative 1 times negative 1. So a negative times a negative is a positive, and so my answer is positive 1. Raised to the power of 3, what do you expect? Well, that's what it looks like in full, and the number of negatives there is 1, 2, and forgot about that one, 3, so it matches the power there, and so that's going to equal negative 1. Negative 1 to the power of 4. Well, I'm not going to write it out in full because I know that a negative sign, a negative number raised to an even power is going to be positive. And I know that basically 1 to the power of 4 is equal to positive 1, isn't it? So we can write it just as 1. And negative 1 raised to the power of 5, that's going to equal negative 1, because I am raising a negative number to an odd power, so my answer is going to be negative. So what you'll notice is that as you increase the powers by 1, what's happening to your answer? Well, quite simply, this is what's happening. As this is going up by 1 every time, this is going from positive to negative, back to positive, back to negative. And so you could predict, couldn't you, that negative 1 raised to the power of 6 is positive 1, raised to the power of 7 is negative 1, etc., etc. And finally on that point, you should note that positive 1 raised to any power you like is going to equal positive 1, isn't it? Okay, so whether it's 2, 4, 6, 8, 7, 3, 9, 0.5, anything, 3 over 2, it's always going to equal 1, and that's handy to know. 1 raised to any power, positive 1 raised to any power is always 1, because you're just timesing by 1 every time, aren't you, and it's not changing the value. Right lads, our final set of questions for this little video, and they're like question 5, but I would allow you to use your calculator. I think the questions in the textbook are asking you to expand them out and then calculate your answer, which I think is a bit long-winded and not really the point of these sort of exercises. So here all I need to really do is put 0.6, so I don't even need to bother with the 0, and raise it to the power of 3 in the way I showed you before. And when you do that, you're going to find your answer is 0.216. So make sure you can get that answer on your calculator. The brighter boys will notice that 6 times 6 times 6 is 216, but I'm timesing 0.6 by 0.6 by 0.6, so there's 3 decimal places in my question, and so there should be 3 in my answer. Don't worry about that if you don't get it, but it can be handy to know. In the second one here, the thing to notice is that I am raising a negative number to an odd power. So I know my answer is going to be negative, so we can write that down straight away, the negative sign. And then I go to my calculator and put in 0.4 to the power of 3, and I discover that that is 0.064. Once again, there would be 3 decimal places in my question, negative 0.4 times negative 0.4 times negative 0.4, so I'm expecting 3 in my answer. Okay, on to the third one. Now, once again, I'm observing that I'm raising a negative number to an odd power. So my answer is going to be negative. And what I can do now is actually make use of an index law that I'll explain more about later. But really this is equal to 2 to the power of 3 over 3 to the power of 3. Okay? 2 to the power of 3 over 3 to the power of 3. And I realise that 2 to the power of 3 is 8. And 3 to the power of 3 is 27. Now if you don't get that, not to worry, I'll explain more about it later. So what you could do in the meantime is just use your calculator and put in 2 divided by 3 in brackets and raise it to the power of 3. And don't forget to call your answer negative, because we know why, don't we? We're raising a negative number to an odd power, so my answer must be negative. Right, with the final example, well, again, you could enter that straight into your calculator. You might find it probably better, however, to write it as a mixed number, and we know how, sorry, as an improper fraction. That's a mixed number. We might want to convert it to an improper fraction, and so it's a case of that times that plus that over that, isn't it? And because I'm raising it to an even power, I know my answer is going to be positive. So really this is the same thing as 5 to the 5 over 4, remember that times that plus that over that, raised to the power of 4. And my calculator is going to tell me that the answer is 2 and 113 over 256. And that's the end of this little video.